All right. So talking about tensors, we also have the tensor product of two vectors. So tensor product of two vectors. Okay, which sometimes, just because of the notation, they call it a dyad. Okay, so let's see what that means. Basically, this means that if you have the product of two vectors, would be, let's say, u dot v. No, sorry, uv, not dot, because then it will be, there is, let me start, there's nothing in between, that's the problem. It's u v this way. This is equal to what? So it will be u sub I, e sub I, v of j, e of j. Okay? Or if I combine the notation, this would just be u sub I, v of j, e I, e j. Okay, so this will be the indicial notation for this. Now this is a vector, magnitude, direction, magnitude, direction. Okay, you combine it. So now if we expand it, what do we have? So we expand it. This could be equal to what? So let's just do the first one. This could be equal to u1, e1. So maybe let me use this notation here. Should be equal to u1, v1, e1, e1 plus, now I keep I equal to 1 and I switch the v, so it would be u1, v2, e1, e2 plus u1, v3, e1, e3. Now I can do the same thing for u2, no? It will be u2, v1, e2, e1 plus u2, v2, e2, e2 plus u3, no, plus u2, v3, e2, e3 plus u3, v1, e3, e1 plus u3, v2, e3, e2 plus u3, v3, e3, e3. So basically you see that the uv in this way is not dot product or cross product, it's just the product of two vectors. It gives you at the end 9 components. Okay, and because this notation is a little bit ambiguous, don't ask me why they did that, but the alternate notation, so an alternate notation is actually to just rewrite u v as u, and this is not crossed because it's crossed with a circle in the middle, v. And this is what they call the dyad actually symbol, but this is basically means the same. Okay? So you will understand why they do it that way. Next, it will be OR in matrix form. This is the same as saying U is equal to. So what we did over here, there's three components, okay? Will be U1, V1, U1, V2, U1, V3, U2, V1, U2, V2, U2, V3, U3, V1, U3, V2, U3, V3. Okay, or also in matrix form, this is, how could you write it? It would be the same thing. If you know that, let's say that U is equal to U1, U2, U3, and V is equal to V1, V2, V3. This will be just a matrix operation. So this matrix is 3 times 1. That will be the same thing as doing now, V1, V2, V3. Where this matrix will be 1 by 3. And if you do this operation, basically what do you get? You get U1, V1, U2, V2, U1, V3, no? The same over here. This matrix here ends up being 3 by 3, which would be this matrix here, which is 3 by 3. Yeah? So basically this is like to do the matrix time the transpose, it will be U transpose of V. Okay? That's the same thing as doing the dyad if you want. Okay? But it's just different notation. All right, so let's do a quick example. This is very simple, but since we're going to use a book, I try to give examples. All right, so example. Find the, okay, let me just call it the dyad now. That way there's no confusion. Of A equal to 3, 7, 2, and B equal to 1, 2, 3. Okay, so the easiest thing is to do it with a matrix. All right, this will be what? U1, V1, so it will be 3 times 1. Let me put it here, 3 times 1. Then will be 3 times 2. This will be 3 times 3. That will be 7 times 1, 7 times 2, 7 times 3, 2 times 1, 2 times 2, 2 times 3. So let's see what we get at the end. 3, 6, 9, 7, 14, 21, 2, 4, 6. Okay, or you could have used that would be what? A cross B, A sub I, B sub J, E of I, E of J, no? So if you look at it, I mean, we're not going to do it, but what would be this? Will be A1, B1, no? A1, B1, E1, E1. So it will be 3 times 1, okay? And we can go through all of them. We'll have the 9 components, so as we did before, okay? Okay, so now we're going to go to the next one, which is vector dyad products. So the first one we're going to look at is a U dot the dyad of the product of the vector VW. So we know that you could rewrite this as what? U dot of the dyad over here. So if we write down this in indicial notation, what does that mean? This will be U sub I, E of I, dot, let's say we are over here, Vj, Ej, and this, let's say, will be W sub k, E sub k. Here you need to pay attention to the indexes because that's what might change everything. So this will give you what? U sub I, V of j. Now we need to be careful here because this will give you what now? This will give you here E of I dot E of j sub k E of k. So now remember this term over here is the same as the delta Kronecker symbol, no? Delta Aj. So that means that this one we only have sense if j equal to I or I equal to j. Okay? So at the end, we just say that this will be equal to what? So let's say j equal to I will be U sub I, V of j. So in that case, this will be equal to 1. All right? W sub k, E of k. Okay, you could have done this one with the other one. You could have done E sub I, E of k, no? Okay, it will be the same thing. All right, now 2, you have space. We're going to look at, this time we're going to have U, V, dot W. Okay? So I'm going to go a bit faster. This would be the same as having u dyad v dot w. Or using indicial notation, I go a bit faster, it will be as having u sub I, e sub I, v sub j, e of j, times, dot, not times, dot, w sub k, e sub k. So this is going to give you u sub I, e sub I, vj, wk, and then we have the ej dot ek. So this one will give you what? U sub I so k equal j, v of j, w of j, e of I. Okay, so what is important here is what? Is that you see that to make the difference between if it's the dial of VW or UV, what is the other thing that you see? Will be the order of the indexes, no? Okay, so that can be pretty tricky, no? All right, to get out. So pay attention to the order of indexes. So order of indexes. Oops. Order of indexes, you see this is u sub I, v, j, w, e, k. This is u sub I, v of j, w of j. Wait, no, here I did a mistake. This is u sub I, v of I, no? This is v of I here. Forgot to put that one. So u sub I, v of I, w, k, e of k. This one is u sub I, v, j, w, j, e of I, okay? All right, so 1, 2, 3. Now what happens if you do instead of the dot product, you do the cross product between a vector and a dyad? All right, so 3. Let's look at what would be the cross of VW. We know we can write this as U cross of V cross W. Okay. So let me restart from here. This should be equal to what? We know the first one would be equal to what? U sub I E of I. Okay. And now we're going to need the cross product of someone. So this will be, let's call this one cross. So this one will be VJ, WK, EJ, EK. Wait over here. I think I'm going too fast here for a second. Okay. We're going good, but I need to be careful here with the notation. So if you remember, when you do this type of operations, what is the first one you need to do? The first one you need to do is the cross product, no? So the first one really we should do is this operation over here, okay? And then the other one. So if we rewrite it that way, let me just rewrite the same line but a bit differently. This will be use of I, E of I, cross Vj, Ej. All right, this will be the first one to do. And then we just need to multiply by Wk E of k. Okay, I think it wasn't smart to write it down this way the first time because this is really the first one we need to do. Okay. So now we do that one. We do the cross product through what? Ij. So we have epsilon Ij. We cannot use k. We can use L. And this will be what? U of I, V of j. And this will be E sub I cross E of j will give you a third unit vector perpendicular that we call here E sub L. Okay? Times Wk E of k. So basically at the end, what we get over here is epsilon I j L U of I V of j Wk E of L E of k. So again, what's going to change here is the indexes. You need to pay attention. So this will be 3 from 1 and 4. If we want to differentiate this one to this one, which would be U V cross W, which would be the same as write it down U cross V cross W. So this time we need to do U V cross W. This time the one we need to do first would be this one over here. So what is that going to give us? It's going to give us U sub I, E sub I. And now we need to do the cross product of this one, which is Vj, Ej, cross Wk, Ek, which basically is going to give you U sub I, Ei. Epsilon of what? We use J and K, so it would be J, K. We need to use the new one, L of Vj, Wk, E of L. All right? So at the end, what we have will just be epsilon J, K, L, U of I, V of j, W of k, EI, EL. So as before, okay, pay attention on the order of the indexes, okay? So look at order of indexes. Because basically the rest is almost identical. It really doesn't matter if it's IJL or JKL, no? It's use of IJ sub AWK. It's just the order of these indexes over here that will make the difference. All right. So now we move to the next one, which is the vector tensor product. vector tensor product. I mean, and all this stuff, as you can imagine, why are we doing that now? Because the stresses, okay, sigma 1, sigma 2, sigma 3 will be tensors, okay? And when you multiply them by, let's say, components of a plane or the Dyad, it will give you, you can summarize all those equation, matrix equation using the index notation. Some of them will be dot products, no, not a lot of them. If you want to have the stress in one direction, what will you have to do? The dot product, no? If you want to find what is the normal, let's say, to a surface to find the stress in that direction, you have to do the cross product. But if you want to find the 9 component of the stresses on a plane, you might have to do the Dyad, okay? So that's why we need to use, to learn how to differentiate all these different ones using the indicial notation. So over here, the first one will be to do V vector dot T a tensor, okay? So what is a tensor? So a tensor is what is new over here is, we use the letter T, and you can have first order tensor, second order tensor, and generally will go up to fourth order for this class. So if you have a second order tensor, what does that mean? So for second order, you will have VI, EI, okay? Dot second order tensor, this means you have, basically instead of having a vector, you will have a matrix. TJK will be a tensor of order 2. Basically, a vector is just a tensor of order 1. All right? Okay? And this will give you what? E of J, E of K. So this will be equal to what? V sub I, you need to be careful here. Now what you need to do, the E sub I, E of J. Okay, this will be E of I dot E of J. Because when you do a dot product, it needs to be the vectors, not the magnitude. So this one, and then what do we have left? We have left the TJK E of K. Okay, so again, this is delta ij. So it will be equal to Vi for j equal I, because otherwise it's 0. You will have what? T ik T of k. Okay? Right? Very straightforward, but be careful with indexes. Okay, next one. So let me summarize here. This will be equal to V dot second order tensor will be equal to V sub I, T, I, K, E of K. All right, next we do tensor. We did vector tensor product. Now we're going to do tensor product. Okay, so we use a second order tensor. So let's say here we're going to have second order tensors, second order tensors T and S. So this is going to give tensor T dot tensor S equal to Tij EI EJ dot SKL EK, EL. So we need to do the dot product between EJ and EK. This will be TIJ, EI, dot product of EJ dot EK. SKL, E of L. This will give you Tij, and again, this will be equal to delta Jk. So we do for K equal J. It will give you what? Tij E sub I S of JL E of L. Okay, or you could just say equal to Tij SJL E of I E of L. All right, so I know this makes complicated, easy stuff a little bit more complicated, but really it makes very complicated stuff a lot easier. So let's do one example for this stuff. So knowing that V equal A cross B, show that V dot V is equal to A square B square sine squared theta. Okay, so all right, so we start from here, V dot V. We know that this one is the same as doing A cross B dot A cross B. If we do it in addition notation, this will give us what? A of I, E of I, cross B of J, E of J, dot, let's see the notation I use here, A of K, E of K, cross B of L, E of L. Okay, so there we go. We need to do first this one and then the other one. So this will give us what? Epsilon ij, we need to find another index, let's say M. A sub I, bj, and because you get EI cross EJ, this gives you EM. Okay, and this one should be dotted with epsilon, KL, probably use N, yes, N, A of K, B of L, E of n. Okay, so this is going to give you what? Epsilon I j m epsilon k l n a sub I bj a sub k b l, and this is em dot en that we know that will be equal to delta mn. So let's say for n equal m, oh, maybe I went, yeah, so this will give what? Epsilon I j m epsilon k l m a sub I bj a k, nothing changes here. Okay, so a sub I bj a of k pl. Okay, or let me just rewrite it as epsilon I j m epsilon k l m a sub I a sub k b sub j b sub l. Okay, so now if we rewrite this using the delta chronicle, remember what we need to do first is k, we do these two over here now, and then we switch them. So this will give you what? Epsilon ik then epsilon jl, because the m is at the end, no? So the same way, epsilon jl minus epsilon, we do the first one, we take the second one, il, sorry, it's delta, it's not epsilon, delta of jk. A sub I, A sub k, B sub j, B sub l. So our first case is what? We can say when k equal I and L equal J, no? So in that case, what are we gonna get? In that case, we're gonna get, so this one will be 1, 1, this will be 0, no? So it will give you A sub I times A sub I, B of J, B of J. Okay? Now, the second case, we have what? L equal to I, and let's say K equal to J. So this will give us minus A sub I A sub j B of j and B of I. Okay, when you do that, so indexes. Okay, so let's just write it a bit differently. So this will give you here A sub I, that remains unchanged, B sub j, B of j, minus A sub I, B of I, A sub j, B of j. Okay? So this will be equal to what? So this is equivalent to having a square, b square, minus, this will be AI, BI will be the dot product. So will be minus A dot B times A dot B. Okay? So this basically that's what we have. Okay. So what is this equal to over here? What is the dot product of two vectors? When you do the dot product, what do you do? Dot A dot B is equal to what? It's equal to AB cos of the angle, no? Yeah. So this will be equal to what? A squared B squared minus A squared B squared cosine squared theta. Okay? So now if we factor out, we have A squared B squared, factor of 1 minus cosine squared theta. But we know that cosine squared plus sine squared equal to 1. So 1 minus cosine squared, this will be equal to sine squared. So basically at the end, what we have is that whether we started that V dot V of a vector is equal to A squared B squared sine square of the angle, which is what was requested from us. Okay? We need to do more of this stuff. All right, I think by now you should have a good idea about the indicial notation, no? Okay, but what you need to do then is to validate with the matrix notation. So let's do one example more and I will stop over there, okay? So I have two examples. I'm just going to do one of them instead of the two of them. So example here is, okay, calculate U dot V cross W using matrix notation, and the other one will be using indicial notation. And in this problem, you have that U equal to 213, V equal to minus 1, 2, and W equal to 2, 2, minus 2. Okay, so this is really equivalent to calculate the area of a parallelepiped, okay? Remember, like one of those squares, so we do U dot V cross W. This is like doing, if you think about it, the cross product, all right? That should be what? Minus 1, 1, 2, times 2, 2 minus 2. And generally you have here I, J, K. But if you have U dot, you will do like U1, U2, U3, no? Okay? What is U1, U2, U3? 2, 1, 3. So if you do this, what do you get? You're gonna get 2 factor of what? Of minus 2, minus 4. Now do we switch the sign? Minus 1 of 2, minus 1 times minus 2 would be 2, minus 4, plus 3, factor, factor of minus 2, minus 2. So this will give you, so this is to calculate the area, so that means the final result is to be a scalar value. So this will be, so minus 12, this is minus 6 times 2. This will be, so minus 2, so plus 2. And this one will be minus 12. Again. So at the end, we're gonna get that U dot V cross W will be equal to minus 22. Okay, so we know part B is going to be probably a lot longer. So part B, we need to do U dot V cross W. So we know this would be equal to what? U sub I, E of I. And then we first need to do the cross product. So it will be V of J, E of J, cross W of K, E of K. So this will give you U sub I, E sub I, epsilon JK, let's say I use L, V of J, W of K, E of L. This will give you U of I, V, oops, I should have done, sorry. Epsilon JKL, U sub I, V of J, W of K, of E sub I dot E of L, which is equal to delta IL. So for L equal I, what are we gonna have? Epsilon of J Ki, 2 u sub A, P of J, W of K, which is the same thing as epsilon ijk, u sub I, B of J, W of K. All right, so I know we have done that before, but let's just do it again. Before doing that calculation, we need to define the value of the different possibilities of the operator, which is what we did on the first assignment, the MATLAB. So we know that for epsilon ijk, you have ijk, you're gonna have the options 1, 2, 3, positive, 2, 3, 1, 3, 1, 2 will be positive, 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 no? And the other case will be in reverse, 3, 2, 1, 2, 1, 3, 1, 3, 2 will be negative. Okay, so let's recall the previous expression. We have u dot v cross w equal to what? Epsilon ijk u sub I v of j w of k. So are the options that we have? Epsilon 1, 2, 3, u1, v2, w3. Okay? Plus, I'm just going to follow this order here, 2, 3, 1, u2, v3, w1, plus epsilon 3, 1, 2, u3, v1, w2. So that's 1, 2, 3. We did the first three positives. Then we're going to have plus epsilon 3 to 1, u3, v2, w1, plus epsilon 2, 1, 3, u2, v1, w3, plus epsilon 1, 3, 2, u1, v3, w1. So, if we look at the values we had before, so we know this one is positive now. So what is u1? It's 2. What is v2? 1. And w3 is negative 2. Plus u2, 1, v3, 2, w1, 2, plus u3, 3, v1, negative 1, and W2, 2. Plus, we go 1, 2, 3, 4. 1, 2, 3, 4. So we go U3, 3, V2, 1, W1, 2. Yeah, this should be negative. So 1, 2, 3, this should be, the next loop should be negative. Correct. Thank you. Negative, negative. So 1, 2, 3, 4. 1, 2, 3, 4. Okay. We go to 2, 1, 3. So we have U2, which is 1. V1, which is negative 1. And W3, which is negative 2. And the last one should be U1, 2, V3, 2, W1, which is 2. Okay, so let's see. This will give us what? -4 +4 -6. No, +6. No, -6. Yeah, -6. So this will be -2. And this should be -8. Okay. So you see these two will cancel each other. So we get -12, -10, -22. As previously. Okay.